All right, ladies and gentlemen, multiplying by powers of 10. Multiplying by powers of 10 is just you have to make the numbers bigger. When you multiply a number by something greater than 1, you're making the number bigger. So we have to make the number bigger here. And making a decimal number bigger means when multiplying by powers of 10 is simply moving the decimal point to the right. You move it to the right, the same number of zeros as there are. So for example, this has 1 0. So we need to change, instead of this 2 being in the ones place, we need it to be 10 times greater, so it needs to be in the tens place. In order to do that, we just move my decimal point 1 place to the right. So then it becomes 327 and 1400ths. The 2 went from the ones place to the tens place. So this is 10 times greater, and that's perfect because I multiplied it by 10. I'm not having to change any of the numbers. I'm not changing any of the numbers at all. Now we're multiplying 26 and 1/10 times 100. If I were to estimate, 26 times 100 is 2600, or 2600. So my answer needs to be somewhere around 2600. Because if I just look at the whole number, 26 times 100, I would get 2600, or 2600. And if I multiply this by 100, I'm moving the decimal point 2 places to the right, once, twice, 3 times, I made it. We get 2610, 2610. I had to add a 0 here. Because just like if this means $5, this means $5 as well. So adding these zeros at the back, behind the decimal point, does not change the value. So now the zero's in the ones place. But I couldn't just leave this blank. Because there are 2 zeros and I needed to make this number 100 times greater, I had to move it twice. So I had to move it twice. In order to move it twice, I had to put a 0 there. Cool beans! 9 and 8600ths times 10. My 9 is in my ones place. I need it to be 10 times greater than what it is, so I need it to be in my tens place. So if I just look at the whole number, 9 times 10 would be 90, but I want this to be in my hundreds, or my tens place. So in order to do that, I got to move the decimal point 1 place to the right. So instead of behind the 9, it becomes behind the 8, and I have 98 and 6/10, which my estimate was 90, but I ignored everything behind the decimal point. I just looked at the whole number, and my estimate was 90. 98 and 6/10 is close to it. And that should be your temperature. Don't be coming if it's not 98.6. I'm watching. All right, 2,700. Or 2 and 7/10 multiplied by 1,000. If I just look at the whole number, 2 times 1,000 would give me 2,000, which means my answer needs to be between 2,000 and 3,000, because this is between 2 and 3. I have 3 zeros. I need to move my decimal point 3 places to the right, once, so I need to add a 0, twice, so I need to add a 0, 3 times. And so then I'm going to end up with 2,700. Why did you not put a decimal point in this final product, Mr. McMurdo? Well, because I know this is in my ones place, and the decimal's implied. If it's not written, it's implied to be behind the ones place. Since it's not written, it's behind the ones place. Let me put 3 up there and give you a minute to do them. Let's take... Okay, I want you to do those three. Should take you just a minute. Then we're going to go over those three. All right. So, again, I'm going to estimate first. You always estimate before you do the actual answer. Don't solve it and then round the answer. When I'm multiplying with decimals, a lot of times I just like to look at the whole number. So the whole number here is 22. If I'm multiplying 22 times 10, then my answer should be around 220. I'm multiplying by 10. I move my decimal point one place to the right. So I'm going to get 222 and 2/10. 222 and 2/10. If I multiply 463 times 100, it'd be 46300. So 46,300 would be my estimate. 463,300. Or I don't know. So we're going to move the decimal point 2 zeros, 2 places to the right. I'm going to get 46301, and then my decimal point. So 46,301. 46,301. 2 9/10 times 10. Move my decimal point one place to the right, and my answer will be 29. Easy peasy live goldfish squeezy. Don't say the answer, please. I already did. I already said the answer. Okay, I'm going to erase these because I want to show you two problems off of this sheet. And by now on all the videos we should have most of them, if not all of them, available to you. I think you may have watched and saw 4 of the problems done yesterday. We're going to do 11 and 12 today. 2,831 times 3. And as I've said 4,286 times, if you multiply, you're always multiplying by a one-digit number times a one-digit number. One-digit number by a one-digit number. 3 times 1. 3 times 3. 3 times 8. 3 times 2 plus 2. Okay, you're only multiplying one digit by one digit at a time. Let's look at a little difficult example. Let's do this is where I get freaked out, people who want to cry and tell me they can't multiply. Well, if you know your one-digit multiplication, if you can look at a multiplication chart, if you're having a test by the state from TEA that I don't like, then you could make a multiplication chart in the graph paper. You do not have to do anything different with this problem than you did with this as far as the multiplication. You're doing one digit at a time. You're only multiplying one digit times one digit. So if I multiply, I start on my bottom factor, bottom, and I start in my ones place. Then it's 3 times 1 is 3. 3 times 3 is 9. 3 times 8 is 24. So what I just did here is this part right here is 831 times 3 with a one-digit factor. What I'm going to do here is going to be 831 times 40 because I'm multiplying it now by 4 tens. I'm multiplying it now by 4 tens. That's why 4 tens equals 40, which means I would just move this 0 down. The reason we put the 0 there is not because your teacher told you some cool catchphrase, bring down a 0, cross off, dump it, or whatever they called it. The reason the 0 is there is because now we're multiplying in the tens place. So we don't put anything in the ones place. We're multiplying in the tens place, so I don't want to put my number here accidentally. I want to move it over so it's in the tens place. And so I put that 0 there to make sure I don't put anything in there. So now, still, one digit by a one digit. 4 times 1, 4. 4 times 3 is 12. So then I have to put the 1 up there. So I have 12 tens, or 102 tens. 4 times 8 is 32, plus 1 is 33. Then we find the sum of those two products, which is 3, 9, 13, 4, 5, 6, 7. 2 plus 3 is 5. 35,733. This is as big of a problem as you are required to know in 5th grade. This is it. So this would be, when I give you an assignment or a test, this would be as hard as it gets. But we just multiplied one digit at a time. And if you put it into your skull that, yes, I can do this, I'm brilliant, this is easy, then you're not going to have a problem doing this. I promise you. I promise you, you can do this. Let's look at the last one, which is 2,899 times 4. Now, if I were going to estimate this, I might make it 3,000 times 4, which would give me 12,000. So my answer is going to be a little bit less than 12,000 because I estimate before I multiply. See how I did that? See how I did that? See how I did that? I'm just saying. 4 times 9. Now, so that's my estimate. My actual answer, 4 times 9 is 36. 4 times 9 is 36, plus 3 more is 39. 4 times 8 is 32, plus 3 more is 35. And if I make a mistake, please pop on and tell me. 4 times 2 is 8, plus 3 more is 11. 11,596. Close to my estimate of 12,000. Since I moved 899 up, or 2,899 up, I knew my answer was going to be less than my actual estimate. My actual product is less than my estimate because I moved this factor up. In your heads that you can do this, and I promise you can. And if you can do the last one we did, if you can do this problem, let's say 799 times 56. If you can do this problem, you can do any division we're going to do this year as well. If you can do this problem, any division we do, you can do as well.
Do we have to do it?
I'm going to do it. You can just watch. And all I do is, if you need to break it into pieces, you're multiplying 799 times 6 and 799 times 50. because 6 is in the ones place, 5 is in the tens place. And so we're going to break it down. But even if I do it the standard algorithm, I am doing 1 digit at a time. I'm doing my 6 times 9, my 6 times 9, my 6 times 7. I'm not doing 6 times 799. I'm doing 6 times 9 and 6 times 9 and 6 times 7. So 1 digit times 1 digit. That's it. That is it. That is it. So 6 times 9 is 50. What is it? 50 who? 6 times 9? Help? 6 times 9, help? Anyone? 54? Is that what you said, 54? So 6 times 9 is 54, plus 5 is 59. 6 times 7 is 42, plus 5 is 49. This, 799 times 6, is what we just did. So 799 times 6 equals 4,994. I'm done with my ones place. I'm moving to my tens place. 5 tens is 50. Since I'm in my tens place, that 0 goes there. And my first number when I multiply is going to go in my tens place. 5 times 9 is 45. 5 times 9 is 45, plus the 4 is 49. 5 times 7 is 35, plus 4 is 39. Then I add these two products together, and 4 and 14 and 19 and 14 and 4, so 44,944. But no matter how big I make these, no matter how many digits your factors have, you're only multiplying 1 digit at a time. If you can do this problem, you can do any division problem that I give you this year. You can do any division problem that anybody gives you ever, if you can multiply by a 1 digit number. That's all multiplication is. I'm not multiplying 56 times 799. I'm multiplying 6 times 799. I'm multiplying 5 times 799. Steps is what it is. Steps. Not all at one time. We take steps. How do you eat an elephant? 1 bite at a time. That is how.